Hello again, everyone. Welcome to another video lesson. 7.2.4, CC3 8th grade book. What else can slope tell you? And we're going to get started. I know some of you are probably upset about my hat, but that's okay. We'll just have to get through it. All right, more about slope. So we've talked about slope before. We've talked about lines. We've talked about what it means. What does it tell you? It is the growth. It's the rate. It tells us how it's changing over time, things like that. So we want to get started on more in-depth slope stuff. So we have 7-67, 7-68, 7-69. Let's go ahead and take a look at what we got here. First off, which is steeper, a line of 2/5 or a line with a slope of 5/2? How do you know and explain? The first thing is you want to look at this 2/5 in terms of steepness, and we talked about this in class, but steepness is how vertically the change goes over 1 unit of horizontal change. So for example, if this goes over +1 horizontally, so the x would be +1, but the change of y is very high. For example, in this case, let's say it's like +5, then that means it's going to be very steep. So the change of y is going to be much greater than the change of x. And so if you just look at this right now, we have 2/5 or we have 5/2. Well, if you just look at it, the change of y and the change of x, y is going to be huge, which means it's going to increase by a lot, and it's only going to go over slightly. In this case, it's only going up a little bit, but it's going over to the right a lot. So the main thing here is we want to have for steepness, a higher change of y per 1 unit of change in x, and that's going to be your thing. So 5/2 is going to be your correct answer. All right, because of the change of y. Next, we have compare the two lines in the graph at right. How are the two lines the same? How are they different? Well, if you look here, they start at 12. So that's for the y-intercept. And the y-intercept is also called a starting point. And that's going to be 0, 12. All right, so that's the first thing, how they are the same. The second thing is, if you look at the slopes, I'm looking at for a point right here. I'm looking for another point that might be good for B. Let's see, this point right here. And so this is my starting point. So I'm going to go up all the way to, looks like 20. So 4, 8. So +8. And then it looks like I go over to the 4. Yeah. And then +4. So for line A, my slope is 8/4, which is 2, all right, or 2/1, whatever you want to put. But I prefer whole numbers myself. And that's going to be the same thing. So, and I'm going to use red. And the reason why I'm using red is because I'm going to go down. Minus, I'm going downward. So I'm going down. If I do a slope triangle like that, I'm going down 8. And I'm still going +4 to the right. So for line B, that's going to be -8 divided by 4, which is -8 divided by 4 is going to be -2. All right, so A equals 2, B is -2. So they are different because they have different slopes. Even though they're the same number, it's still different. However, the change of their x and y is similar, but they're not the same. So different slope. Different slopes. Or you can say growth, or you can say rate. The growth rate, you can say, yeah, those are the main things that we like to focus on. Each line on this graph describes how much money a person has in their wallet over time. Well, I like money. I like me some money. So let's talk about some money. Let's use green. Explain what has happened to the amount of money each person has. Be specific. So in terms of the context, money for A is going positive. And money for B, I'm going to use red again, is going negative. So that's what's happening. So specifically, we know it's going to be -2 So -2 what? So -$2, because that's what it says right here, per day, because that's the time in days. And then for the A, it's going to be +$2, so $2 per day. That's how much they are making over time. C, to describe a person A's amount of money is changing, the unit rate or the slope, the unit rate, represents that in an added each day. So every day they are adding $2 for line A, $2 a day, $2 a day, $2 a day. Since the money of value is increasing, the slope is positive. So it's going up and to the right. But what should you do when the value is decreasing? How should the decrease be reflected in the rate? Well, if it's decreasing, right, decreasing should equal negative. And that's down to the left. I mean, down to the right. Sorry, not down to the left. Down to the right. And that's what you should be focusing on for slope. Moving to D, remember the slope ratio compares how the change of the y-axis compares to the change of the x-axis. Again, how do I write that? The change of y in comparison to the change of x. You can even say change of y and to change of x. Whatever ratio, slope, fraction, doesn't matter. A line that goes up from left to right shows positive slopes, and a line that goes left to right going down is negative slopes. So again, the main thing you want to focus on is goes up, left to right, and then the red was going to go down. Oops, I want a red. Go down. Down is the key word here, and then up is the key word there. Find the slope of each line in the graph. We already did that, so we're going to move on. 7-69, what is it? What if it does not grow? Interesting. What happens if it does not grow? Describe each line in words. All right, so A, is it increasing or decreasing? Increasing. Increasing quickly. Starting at $5. Let's go for B. Let's use blue. B is starting at $4 and doesn't increase or decrease. And then C is going to be red. C starts at $1 and decreases slowly. All right, line B is different from all the other lines. As the x value increases, what happens to y? So x increases as it goes to the right, because look, now it's 10. It went from 5 to 10, 0 to 5 to 10. So it's increasing, but y stays the same. Oops, I spelled y backwards. Y stays the same. All right, so that means there's no growth. So that means no growth. What is no growth? 0. That means it's actually 0. So for example, the change of y and the change of x, the change of y, did the y change? No. And then the change of x, does it continue to grow? Yeah, it does, by 1. Every single time y doesn't change, it goes over 1. So that means there is 0 growth, so that means it's a flat line. 0 means flat line, all right? No slope. Think about like when you're skiing, right? So if I have a mountain, right, and I'm skiing downhill, and I have my skis, and then I'm like, woo, I'm going downhill, all right? So that's well, it's like scary. It's a drop, right? You don't want to go negative. You can actually kind of go uphill in a sense if you had someone for example, on their skis, but they were being pulled by maybe a snowmobile going uphill, so you can still go. But yeah, anyways, I digress. Let me go back to the problem. But yeah, so let's see. Describe each line in words. Is it increasing or decreasing? Yes, okay. Line B is different. Yes, we already did that one. C, change in y, change of x. Pick 2 points on line B. Use your numbers to represent. Okay, so we're going to go 0, 1 and 0, 10. And that means the change of y is 0 and the change of x is 9. So that means it's still 0. So that is our point. So let's say it is there, and then I did here. And so that means it was my slope, and that means 0 slope. Recall that the units for the change in y are the same as the y-axis, and the units in the change of x are the same for the x-axis. What are the rates growth of lines A and C? Okay, so growth here, so we start at 0, 5, and we go up to here, which is 2 over, so that's 2, 10. So all I'm going to do is the change from 0 to 2 is plus 2. The 5 to 10 is plus 5. So my y is 5 and my x's are 2. Remember, x and y. X is on the bottom. So that's going to be 2.5 or 5 halves. And then the growth for C, so I'm going to start at 0, 1. And I'm going to go all the way to, looks like this one right here. That looks like 5, 6, 7. So that means it's going to be 7, comma, -1. So all I did is from the change for my x and the change for my y is going to be a -2. And that's going to be a 7. So it's going to be -2/7, it looks like. Because this is subtracting by 2 and this is adding 7. So that should be my slope for line B. It says be sure to include units. So this means that I'm losing $2 every 7 days. All right. And this one is like I'm gaining for this one, for line A, I'm gaining $2.5 per day. I love making money. Got to make money every single day, right? All right, moving on to E, express the rates, and D is unit rates. Okay, well, I already did that. It's going to be $2.5 and per day, and then -$2 for every 7 days. That's what I would say. Going on to 7-70. All right, personal trainer to prepare for biking long distance. Antoine has been trying to keep a steady pace as he bikes. Ever since his hometown has so many hills, he ends up biking faster and slower to different parts of his ride. That makes sense. To track the distance and time when he trains for the triathlon, we're going back to the triathlon stuff. With a push of a button, he can set a record to date. Then at the end of his workout, the watch gives a list of data. Okay, so here's all of his data. Awesome. On his first bike around town, he recorded several distances and times. They're shown in the table above or to the right. Does he appear to be traveling at a constant rate? Well, let's just take a look. Let's just take a look. So from here to here, that's +3 and then +1. So that right there, for me, is going to be 130. You're going to try 1 mile every 3 minutes. So let's try this one. 12 to 16, that's +4. And then this is +1.5. And this one is +3. And this one is +1.5. So even by looking at these rates right here, these changes and these changes, they're not the same. They're not the same. And then if you look at this one right here too, they're all 3 different. So no, he's not traveling at a constant rate because we have 3 different slopes or 3 different types of changes. Draw and label a graph that extends to 40 minutes on the x-axis and 15 miles on the y-axis. Plot Antoine's time and distance on the graph. Okay, so now I got to get graphing paper. All right, so let's take a look at this. And let's take a look at this. And we'll take a, oh, I don't want to go on Pinterest. Oh no, I want to print this out. Go here. Go there. Print graph here. Okay, let me just go to print graph paper. There we go. I should pause the video, but I'm really sorry I'm not. Okay, there we go. So let's rotate this. So we have 40 minutes on the x-axis, 15 on the y. So I'm going to go ahead and make my line here. Let's use black. All right, let's move this over here. All right, so this is 0. All right, so we need 40 on the x. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here's 20. 1, 2, 3, 4, 5, 6, 7, 19. So that's 39. Close enough. All right, and then we need 15 miles on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5. Okay, so we should be good now. All right, plot Antoine's time and distance on the graph. So we're gonna go ahead and clear, I don't wanna clear it because I don't wanna remove anything that I need. So I'm just gonna go ahead and plot these. Come on. Just need to get some space. All right, I'm gonna go ahead and pause it. I mean, you don't really need me for this. I'm just gonna do it real quick. Okay, and we're back. So I plotted all these, 3 and 0.5, 5, 1, 8, 2, 12, 3, 16, 4.5, and 19, 6. So I don't know why I made us go all the way to 40, but that's what we did. So, all right, draw a trend line that best represents Antoine's data. This extends it's to predict about how long it will take to bike 10 miles, his normal long distance workout. Okay, so here's the thing. We are not drawing a perfectly like a perfect line because with all these dots. So we're going to try to get a best estimate. So the thing is, give me 1 second. I'm sorry about that. All right, so the thing is that like in order for this to be realistic, we would need to start at 0, 0 because you can't travel anywhere without any time. So we're going to use a different pen. We're going to use, let's use green. And let's start here. And we got to try to fit as many lines as possible through here. So I'm going to go ahead and that's probably a little bit too high. So let me try one more time. Get rid of these. I need to go lower. I need to pass through as many points as possible, but I also need to make sure that I can like split them. So I think that's pretty good. All right, that's probably the best I can get with the technology that I have. So yeah, that's going to be our trend line. So basically, there's some points below it, there's some points above it, but basically, it's kind of like averaging out the dots in a specific line. So let's go ahead and continue on here. What is Antoine's general rate during his bike ride? Find the slope of the trend line. So, oh no, I just closed it out. Oh no. All right, so basically, if you can go back and pause it, the trend line is going to be, let me just pause real quick. All right, so I tried and all that stuff, but basically, so we did a line drawn. I can't believe I closed it out. But the general rate during his bike ride, the slope that you should find, I'm just going to give you the answer here, should be approximately 15 miles per hour. So if we look at this chart here, we start at 0, 0, and then we want to find a point where it actually hits, and we want to find just a slope triangle. So based on your graph, it could be about 15, it could be 12, it could be 18. It depends on how you draw it, but we want something around the 15 miles per hour. All right, that's pretty much it. Sorry that I closed out all my stuff, but that is the case that happened. I hope you all had a great time watching this video and a great day, and I will talk to you all soon. Bye.